Okay, so part one, we looked at balancing equations. Now this is part two, where we actually work out the molar enthalpy change based on our bond energies. So in your exam, you'll be given a table with the bond energies of each different individual bond. For example, we've got CH, OH, O double bond O, C double bond O. So it's very, very important here that when you're looking at our CH bond, it's a C single H, which is 435 kilojoules per mole. But if you look at our O double bond O, for example, it's 498. Just because it's a double bond, we don't times this 498 by 2. We just leave it as 498. So the 498 is for the double bond. There's no two separate bonds here. They're just looking at a double bond, which is 498 kilojoules per mole. So that's very, very important. Okay, so when we're looking at bond energies, it's very, very important that we look at our displayed formulae. So usually they'll give you the displayed formulae for each molecule of the equation in the question. Just in case they don't, we just look at how to do the displayed formula of this reaction. So for example, CH4, C, 4 lines represent our bond, and we have 4 H's. So that is CH4 plus 2O2, so O double bond O and O double bond O. So I've just looked at this, for example, just got O double bond O and those CH bonds. And then we look at our products. So we've got CO2. So if you look at this table here, we've got C double bond O. So we know that our CO is going to be double bond. So first of all, we have our CO2. Let's draw that. C double bond O, double bond O. And we also have 2H2O. So that's going to be plus H O H, because they're single bonds from our table, we know that, and O H. So we also got that from our table, O single bond H. Okay, so our step one now is looking at the sum of the bond energies of the reactants. So we also call this energy in. So this is referring to the energy that is taken in to break the bonds of the reactants. To break all these bonds, we have energy in. So the first bond we look at, if you look at a table, we've got CH4 and 2O2. So you're going to have the CH bonds, which are 435 first. And we have 1, 2, 3, and 4. So 1, 2, 3, 4. I'll just number them just to make it easier. 1, 2, 3, and 4. So we've got 4 CH bonds. So I'm going to just write here C and H. CH, apologies for that. CH is 4 times 435, which is 1,740 kilojoules per mole. Okay, and our next one is O double bond O, which is 498 kilojoules per mole. And because we've got 2O2, if you look at our bonds again, we have 1 and 2. So 1 double bond, 2 double bonds. So therefore, if you look here, O double bond O is 2 times 498, which equals 996 kilojoules per mole. And if we total them together, we get 2736 kilojoules per mole. Okay, so we move on to our next step then. So our next step, I'm going to call this step 2. So this is the steps that we should always follow. There's 3 steps that we need to follow when calculating molar enthalpy change from bond energies. So because we've looked at our sum of bond energies of the reactants energy in, now we need to look at our energy out, so our bond energy of the products. So we got here sum of bond energies of the products. And we will call this energy out. Okay, so here we've got C double bond O. Again, we have one bond, so one double bond and two double bonds. If we look at our table, 805 kilojoules per mole for CO bonds. So first of all, we need to do 2. So C double bond O. We're going to just put an arrow there, 2 times 805, which equals 1610 kilojoules per mole. And then we also have our OH bonds there. Here we've got 1, 2, 3, and 4. So OH here, just draw another arrow, 4 times, how much was it in the table? OH is 464. So 464, which equals 4 times 4 is 4, 1,856 kilojoules per mole. Okay, and then again we total these again. So we have a total of 3,466 kilojoules per mole. Okay, so energy in 2736 we've totaled from our reactants, so our CH bonds and our O bonds. Then for step 2 we've looked at the products, which are the CO bonds, C double bond O, and your OH bonds, which gives us a total of 3,466 kilojoules per mole. Our final step, so now step 3, called the step 3, is our energy change. So energy change is going to be our energy in, take away, energy out. We could even say step 1, take away step 2. Whichever one you prefer, or you can even say the sum of the reactants. This means sum in math terminology, by the way. Take away sum of products. Sigma, capital sigma. So we've got sum of reactants, take away sum of products as well. So any of these 3, whichever is easiest for you to use, you can use any one of these 3 equations. Energy in, take away energy out. Step 1, take away step 2. Sum of reactants, take away sum of products. So all we do now is we take our step 1 answer, which was 2736. So 2736, take away, and our answer here for energy out was 3466. So 3466. So 2736 take away 3466 gives you minus 730 kilojoules per mole. There we go. So minus 730 kilojoules per mole. So the minus value is very, very important. So because it's minus 730, that negative value or the negative sign indicates that this reaction is exothermic. So that means when we look at our equation, our energy in is less than our energy out. So energy is released in this reaction. Okay, so anytime that you see a negative sign, if your energy in is less than your energy out, then the reaction must be exothermic because energy has been released.